Hi everyone, let's take a look at the following question. Number 2 on page 196. Determine where g of x equals to 2x cubed minus 3x squared minus 12x plus 15 is increasing and where it is decreasing. Step 1. Find the derivative. G prime equals to 6x squared minus 6x minus 12. To find the critical point, you have to set this to be 0. You're going to solve for x. There's a common factor of 6, which you can bring to the front. If you continue factoring, x squared minus x minus 2, this is simple factoring, which means it will be x plus 1 times x minus 2. So x equals to negative 1 or positive 2. Always form the habit of finding the actual points and not just the x values. If you plug negative 1 back to the function, that's going to give you negative 2 minus 3 plus 12 plus 15, and that's going to be 22. Likewise, if you plug in 2 back into the function, that's going to be 16 minus 12 minus 24 plus 15, which is negative 5. Now, in terms of increasing, decreasing, you can draw a number line, negative 1 and 2. Again, the slower method is you divide this into 3 different intervals, and you pick a number for each case respectively. The faster approach is to recognize that y prime or g prime is going to be positive even. So again, just by looking at the first number, 6, that's going to be positive. The exponent is a 2, which makes it even. So the fact that it's positive even, this means it's going to go from quadrant number 2 to quadrant number 1. So it's going to look something like that. And again, can tell because the exponents are 1, which are odd, so it'll cut right through. So this is going to be increasing, decreasing, and increasing, just like that. So this means the interval of increase is when x is less than negative 1, when x is greater than 2. The interval of decrease is when x is in between negative 1 and 2. Now, before we keep going, I'm going to give a little bit more. So I know they didn't ask you to graph this, but give me a chance to over-deliver. So if you go back to the critical points, again, this is just a sketch of what it looks like. The scale is not perfect, I know. But if you look at this, one critical point is going to be negative 1, 22. The other critical point is going to be 2, negative 5. And again, the fact that it's increasing, decreasing, increasing, the graph will look something similar to this. Again, we haven't talked about concavity. I haven't given you all the techniques, but that's what the graph looks like. Let's keep going. Number 4, A, C, and E. Find all the critical points of each function. So for these ones, we'll just find the actual points, and then we'll just continue. We're not going to really graph them anymore. In the first case, y prime is going to be negative 4 plus 16. Set this to 0, solve for x. When you bring negative 4x to the left, that becomes positive 4x. the opposite of multiplying by 4 is to divide by 4. Again, form the habit of finding the actual point, not just the x value. You can take the calculator. When you work it out, y is going to be 1. So the critical point is going to be located at 4, 1. Let's keep going. For part C, the function is going to be x to the 4 minus 4x squared. In this case, when you find the derivative and you set it to 0, y prime is going to be 4 x cubed minus 8x. There's a common factor of 4x you can bring to the front. In the brackets, it's going to be x squared minus 2. This means x could be 0 and plus or minus root 2. So again, notice I'm going slightly faster. Make sure you're connected. And if you're not, go back and ask yourself, did you do enough homework? Again, form the habit of finding the actual points, not just the x values. Now, of course, instead of saying root 2, you can always round this to 1 decimal place. That's perfectly fine. Again, if you take these numbers and you plug it back into the function, in the first case, when x is 0, y is going to be 0 as well. When you plug in exactly root 2, and you take root 2 to the 4 minus 4 times root 2 squared, that's going to give you negative 4. And again, it's the same answer because if you really look at it, this is an even function. So you can imagine the symmetry, which is with respect to the y-axis. One more, 4c. In this case, y equals to x squared minus 1 divided by x squared plus 1. To find the derivative, you have to apply the quotient rule. Square the bottom, copy the bottom to the top, multiply by the derivative of the top, minus, second last step, copy the top, multiply by the derivative of the bottom. Again, think factoring. There's a common factor of 2x you can bring to the front. And the brackets will be x squared plus 1 minus x squared plus 1. So again, I hope you're connected. You can dismiss the denominator in this case because if you look at the restriction, x squared plus 1, quantity squared cannot be 0, x squared plus 1 cannot be 0, x squared cannot be negative 1, so there are no restrictions, which means the only critical points is going to be found in the numerator. And again, just remember, to find the critical points, you want to set the derivative to be 0, or sometimes you have to look at the x values that makes it undefined or does not exist. And in this case, only the numerator is going to be important. When you collect like terms, that's going to be 4 times x, which means x is going to be 0. Again, form the habit, find the actual critical point, not just the x value. If you plug 0 back to the function, that's going to be negative 1 over 1, which is negative 1. And that's how you do number 4, A, C, and E. And this is how you do number 2 on page 196. I hope this makes sense.